Hello dear friends, and welcome once more to this video we have here. In this video friends, we shall be looking at the correction of the mathematics with mechanics, the Cameroon GCE June 2021. We shall be looking at the question that was based on ladder problems. As you can see friends, we have the setup here, and the demand of the question wants us to prove the tension to find other similar quantities. So friends, please, for a quick reminder, if you're new to this channel, don't forget to subscribe to the channel so that you can have access to all our great contents. If you have any of your friends that find this concept very tough, please do well to refer your friend to our channel. We offer free lessons to students. We also have WhatsApp group where we help them to prepare so well for their exam. So guys, let's get started. Awesome friends, awesome. All right, let's have the question here. The question is on screen already, and friends, the question reads that a uniform rod AB of mass 2 mkg and length 4 meters is smoothly hinged at the point on the vertical wall. It is supported in the horizontal position by a light inextensible string attached to the rod at point C, where CB is equal to A, and the other end of the string is attached to the point D on the vertical wall, where D above A, such that the string makes an angle of 6 degrees with the wall. A load of mass mkg is placed at B, and the system is in equilibrium. A, show that the tension in the string is 16/3 mg. Then the B part, find in terms of M and G the horizontal and vertical components of the reaction force at the hinge. And C, determine to 1 decimal place the angle with which the reaction force makes with the rod. Alright, so friends, in such a question, all you simply need to do, friends, all you need to do in summary is to take your time and read the question out. Okay, take your time and read the question out. Don't bother if others are writing and you're not writing. Don't bother. Take your time to read the question out and try to figure out what the scenario looks like. And in such a question, guys, you must have to draw diagrams if you want to picture out exactly what's happening. Okay, so let's draw some small setup, guys. We are going to have the wall. Okay, since they're talking about a uniform rod of mass that which is hinged in a vertical wall, so this is going to be our vertical wall, guys. We are going to be inserting the quantities bit by bit. So that's the wall. Then this is the rod. Okay, this is where the rod is hinged, and they said the rod is of they name the rod as AB, right? So here can be A, and the end here we can call it B. Good. Then friends, we are going to have the string, because they said the string is being attached to the rod right at point C, where CB is equal to A. So this point where the string is being attached on the rod, we can call that point C. Good. And we're being told that CB is equal to A. That's the distance from C to B is A. So here we're going to have CB. We're going to call that the distance to be A. Good. That's good. Then they said the other end of the string is attached to the point D on the vertical wall. So this point is the point D. Okay, that's the point D. We can call that the point D. Great. That's good. All right, friends, and they said on the vertical wall where they said where D is above A. Good, so that the string makes an angle of 6 degrees. All right, friends, with the wall. So the angle with which this our string makes with the wall is 6 degrees. So we can insert here that here is 60 degrees. Good. Then now they said the system is in equilibrium. All right, so friends, they also told us that a particle of mass m kilogram is being attached at B. Good. So this is what we have. The particle is of mass m kilogram, so its weight has to be what? Mg. That is the mass times the acceleration due to gravity. Good. Then friends, let's not forget that the question gave us the mass of the rod, right? And the mass of the weight of the rod is going to be concentrated. It's going to concentrate itself at the centroid. Okay, that's because the centroid of this rod is the point where where majority of the weight of the rod concentrates. So, and since the rod is uniform, that therefore means the centroid of this rod is going to be what? Half the distance of the rod, half the length of the rod rather. So this is going to be where we are going to have the weight of the rod, and we can call that, since the mass is 2 kilogram, is going to be 2 mg. That's great. Then friends, we also have other quantities. This our the distance from the center of this rod to one end of the rod, since we were told that the rod has length of 4a, so that for me this distance has to be 2a. Good. And this other distance from the center to this other way also has to be 2a, but since the distance from C to B is already a, that therefore means the distance from where the weight is acting to the point C has to be a. Good. Such that a plus a gives us 2a, 2a plus 2a gives us 4a. Good. That's what we have. Then friends, we also have to insert these quantities. We also have the string also should have some tension. We can call that capital T. Great. That's it. Then friends, we should know that this angle is also angle 60 degrees. The angle with which this the angle with in fact the vertical component of this of the angle in which the string makes with the wall has to be 60 degrees, and the component is simply going to be what? T cos 60. Good. T cos 60. And likewise guys, this component that is parallel to the rod has to be, it also has a component which is now going to be T sine 60 degrees. Great. That's it. Then friends, there's going to be some reaction force at this at the where the rod is smoothly hinged. Okay, this is going to be the vector that can represent it in this form. This we are going to have the reaction force. We can call that capital R. Good. That's great. And it is going to be at some angle. We can call that angle omega. Okay, that's the angle in which the reaction force makes with the rod. We can call it omega. Great. So friends, we have our diagram in this form. I'm sure everything is set up, but friends, let's also resolve this our reaction force. Okay, it is going to have two components. It has the vertical component which has this vector. We can call it R sine omega, since it is opposite to this our angle omega. This is going to be R sine omega. Then the component that is that is horizontal, we can call it, that's the vector representing it, we can call it R cos omega. Great. That's the vector representing it. So friends, I think everything is set up right. Everything now is set. All we have to do now is to go ahead now to prove our result. Okay, now the first question wants us to show that the tension in the string is 16 mg. So friends, most mistakes that students will make is that they are just going to go about summing all the forces. Okay, because they're going to have R's, that's they'll say the system is in equilibrium. That therefore means that the forces should be balanced. That's good. That's a very good concept to take note. But friends, they will say that R sine omega plus, that's the upward force should be the same like the downward forces. That is R sine omega should be the same plus T cos 30 should be the same like 2 mg plus mg, which is 3 mg. But R sine omega is not known. Okay, so you cannot go by the forces. So in this case now guys, we have to take moments. Okay, we have to take moments. So we shall be taking our moment about an axis through A. Okay, A is simply the point where the rod is being hinged to the vertical wall. Great. So we are going to take moment about an axis through A. By so doing guys, if we take the moment about an axis through A, we are going to neglect all the forces acting at A, because the forces acting at A, we have the reaction force R, which has two components, the vertical and the horizontal component. So when we take moment about this point now, we have neglected all of the forces acting at this point. So we're now going to see that the forces, the three forces that are going to bring about moment about this hinge are going to be the weight of the rod and the mass that is being placed at B, as well as the vertical component of this tension. Okay, those are the three forces that are going to that are going to try to cause about some moment. Great. So friends, since we have been told the system is in equilibrium, that therefore means that the sum of clockwise moment should be the same like the sum of anti-clockwise moment. Keep in mind friends that this t equals 6 degrees, 6 to do what? 6 to cause this our rod to rotate in the anti-clockwise sense, while the weight of the rod and the mass placed here 6 to make this rod to rotate in a clockwise sense. Good. So now sum of clockwise moment, guys, should be same like the sum of anti-clockwise moment. So the anti-clockwise moment that we have, guys, is what? T equals 60, right, times the perpendicular distance from the pivot. Since this distance is a, this is 2a, so a plus 2a gives us what? 3a. Good. That's why it is equal to, now friends, the weight of the rod is what? 2 mg, right? The distance from the rod to the point of rotation, or the distance from the weight of the rod to the pivot or to the fulcrum, it is what? 2a, plus now the mass that is being placed at B, which is mg. The distance from this mass to the point where the rod rotates is what? Is 4a. Good. That's why we have in this form, guys. If we simplify so well, guys, we are going to have 3a over 2. Keep in mind that cos 60 is a half, okay, is 1/2. So the 1/2 divides this 3 to give us 3a over 2 t equal to, now friends, this is 2 times 2 is 4, so we have 4 mg plus 4 mg, which gives us 8 mg. So if you multiply, and the a they can cancel on both sides now, so if you multiply all through by 2 and divide by 3, we are going to have the tension to be 16 over 3 mg as required, guys, as required. So friends, that's the tension in which we're asked to show that the tension is 16 mg over 3. That's it, guys, that's it. Then friends, the next part is saying that we should find in terms of m and g the horizontal and vertical components of the reaction force at the hinge. Alright, so they simply want us to find r cos omega and r sin omega, because these are the two components of this our reaction force. So friends, by so doing, we are definitely going to sum up the vertical and horizontal components of our forces. Okay, we are going to resolve the forces horizontally and vertical. Now guys, from the resolving these our forces vertically, we see that we have r sin omega, whose vector points upward, and r cos and the t cos 60, whose vector points upward. So we are going to sum up these two forces. That has to be equal to the weight of the bar plus the weight of the particle that was placed at B. Good. So by so doing, guys, we are going to have t cos 60 plus r sin omega, which is the same as the sum of these two weights, guys. 2 mg plus mg gives us 3 mg. Good. By so doing, r sin omega, guys, turns out to be, keep in mind that our t is what we know, then cos 60 is what we know, right? So if you plug in everything, guys, we are going to have 3 mg minus our t is 16 over 3 mg. Cos 60 is a half, okay, is a half, so it reduces this 16 to 8. That's how we have it here, guys. So simplifying everything, guys, gives us our r sin omega to be the same like 1/3 mg. Great. That's the answer, because they ask us to find the components. We have r sin omega equal to 1/3 mg. Then friends, to get r cos omega, we simply sum of the horizontal forces, or the horizontal forces should also balance. It therefore means that this vector, this r cos omega vector, has to balance with what? This t sin 60 vector. That therefore means that our r sin omega, guys, is simply going to be t sin 60. But what is our t? Our t is 16 over 3. Sin 60, guys, is root 3 by 2. Okay, I have a video where I explained the easiest way to come out with those special values for the sine of angles. Okay, the sine, cosine, and tangent. So guys, make sure you watch the video. I'll put the link in the description below for your convenience. It's so important. If you put decimal values, guys, they are going to give you your method mark, but your accuracy mark they will not give you. You're going to have M1A0. So guys, take note. Alright, so if we simplify this way, guys, we're going to have r cos omega to be the same like our t is 16 over 3 mg then sine 60, like I said, is root 3 by 2. Simplifying square, guys, gives us our answer to be the same like r equals omega equal 8 root 3 over 3 mg. Alright, so that's the answer. That's the horizontal component of the reaction force. Then the C part wants us to determine to 1 decimal place the angle with which the reaction force makes with the rod. So they just want us to get the value of omega. Alright, so friends, let's look at it. So guys, since we are short of space, we'll just answer it over here. Okay, let's just adjust the sign and answer it over here. Awesome, that's great, that's great. So friends, before then, let's call this r sine omega equals 1/3 mg. Let's call it equation 1. Okay, then we call r equals omega equal to 8 root 3 over 3 mg. Let's call it equation 2. Good. Keep in mind that we have to solve for the value of omega only, not solve for r. So by so doing, we are going to take equation 1 divided by equation 2. Okay, we are going to take equation 1, as you can see, it's divided by equation 2. That is going to mean that if we divide equation 1 by equation 2, r will cancel r, right? R cancels r. Then sine omega over cos omega gives us tan omega. Good. Then guys, keep in mind that we have a 3 here, right? And we have a 3 here, so they can cancel. So by so doing, we are going to have tan omega to be the same like we have 1/3 mg. Then here we have 8 root 3 over 3 mg. Mg there and mg they can cancel. Then we have 3 here, can cancel with 3 here. So we are just going to have our answer to be, we have tan omega to be the same like 1/8 root 3. So friends, if you punch it on your calculator, punch it and make sure your calculator is in degrees, guys, you're going to have an answer of approximately 4.1 degrees. Great. So guys, that's the angle to 1 decimal place with which the reaction force makes with the rod. So friends, thank you so much for watching the video. Thank you so much. I hope you found it useful. Please put in the comment section down below what you think about this question, and have a blessed day.